Now, if I was going to go out and measure something, I'd want to first agree on how we're going to do it. If I were to send you into a school full of elementary school kids and I just wanted to ask, well, how big are the kids? It wouldn't be helpful if one group came back having measured height and another group came back having measured weight. We wouldn't know how to compare the data. So we're going to have to decide upon the tool that we're going to use to measure the thing that we're going to measure. Now, psychiatry is no different. Usually when we're using a standardized measurement tool before the treatment, this is often known as the baseline, and then again, we'll use that same tool after the treatment. This is known as an endpoint. Sometimes there's a longer-term follow-up where we see how well the effects of the treatment persisted over a longer period of time. Now, there are many different tools that we use to measure different illness symptoms and severity, and it's worth looking these up. There's a number of them are listed here on this slide, and just become familiar with them. You may be familiar with something like the PHQ-9, but understanding these measurements helps us to begin to understand effect sizes, which I'll talk about shortly. Now, if you've ever looked at a study graph and noticed that both the drug group and the placebo group were improving, you're seeing something real. But let's take a look at this graph. The top left corner is where both groups start, and the degree that they come down on the y-axis is a measure of how much they've improved. More improvement, the more they move down over time, and that's the x-axis. Now, when people enter studies at their worst, scores often improve naturally. This is called regression to the mean. Now, even placebo groups receive attention, monitoring, and care. And remember, they're usually blinded, so the researcher and the subject don't know what they're getting. And that alone, that care, can improve symptoms, in what we call nonspecific effects of treatment. And there's also something called the Hawthorne effect. When people know they're being observed, their behavior changes. So we don't just ask, did patients improve? We ask, did they improve more than placebo, and by how much? Now, the first thing you should look into when you start to look at the results of a study is the p-value. P, in this case, stands for probability. A p-value shows us how likely it is that the observed difference happened by chance. Or put differently, what was the probability that we incorrectly rejected the null hypothesis, which would make the findings a false positive? By convention, a p-value below 0.05 is considered statistically significant. It's another way of saying that there's a 95% chance that the results actually report something that isn't just a fluke. Another way that we sometimes report this is with a confidence interval. A confidence interval is the space between where we would find 95% of our outcomes. You can see this reported as a range of numbers in the text of a study or graphically in what are known as whisker bars. If you look at a line graph or a bar graph, you'll often see these vertical lines above the data point. Those are known as whisker bars. And that shows the range of the data that the different subjects reported. And sometimes there's a lot of variability in how people did in the study, and that confidence interval can be pretty wide. When the findings group closely together, like the arrows on this target, you'll see most of them are grouped together around the yellow and red rings, and there's one outlier in the blue circle there. We can feel more confident in those findings than if, say, the arrows are scattered all over the place. When the arrows are scattered all over the place, we don't really know if the results are concentrated around one area. But statistical significance or confidence interval doesn't tell you how big the effect was, the clinical effect. So, for example, large studies can find tiny differences that really don't matter clinically. Statistical significance shows you if a difference exists, whether it's meaningful, and most impactfully, it doesn't tell you if it can help your patients. That's where effect size comes in.